In this video, I'm going to compare two queue implementations. One is based on linked list and another is based on priority queue. So the linked list based is the one which preserves the insertion order, which means that the order in which the inputs are inserted, that order is maintained. So in this case, 5 is the first element, third is the second, and so on and so forth. So 5 is the first element entered. So when you poll the queue or do peak operation or remove operation, you will get 5 as the output from this queue, and then once it is removed, it will be 3 and then 4 and 2. The priority queue based of implementation preserves the natural order unless you specify a custom comparator. What does that mean? Natural order, like in this case, it is integer that this queue is going to store. So the priority queue will maintain the order in ascending manner. So once all these elements are entered, when you see the contents in the object, you would see that the smallest element is on the top of the queue. So if supposedly at this point or after this point, if you try to peek into the queue instead of 5 in the case of linked list queue, you would get 2 as the answer. And then you can do custom comparator based priority queue as well. For example, for much like real world problems that you would solve, you will work on complex objects. For the demonstration of a custom comparator, I have taken a simple example where I'm going to store objects of car type, and in car what I have is that I'm saying price and make, and my comparison is that the price higher is much high priority item. So in the custom comparator, I'm comparing the price, and I want my priority queue to give more priority to the car which costs more. So as you enter or create add contents in the queue, it would check whether the new entity being entered, how does that stack up against the other entities in the queue, and will put the more priority high priority one at the start of the queue, so that when you get the item from the queue, the high priority one is retrieved first. This is very useful in many applications where you want the items which are high priority to be served first. Now let's debug it and see for ourselves the points as I just mentioned. So linked list based, it preserves the insertion order. So we have 5342, no drama in there. The priority based queue preserves the natural order unless specified otherwise. So it preserves the ascending order of the integer data that we are trying to put it into the priority queue. The result is 2345. And then with custom comparator, so sorry if the prices are not right. I don't want any of the car lovers to get offended, but yeah, this is the best example that I could come up in short time. So pardon me if the prices are not right. But we added 40,000 and then 50,000. So the item at 50,000 should be on the front of the queue, and that is how it is. And rest of the item are already sorted in that manner, so there is no change for them. So that is a simple video to compare these two different implementations, and you can have your own custom implementations for the queue interface. For much complex applications you would need that, but for more or less simple problems, these default implementations should be good enough for you. In terms of time complexity, so like the linked list based queue is based on linked list. As long as you want to get the first element, the time complexity is o constant, o1. And for queue, that's how it should be. Like you keep adding the elements, and you just want the first one to be pulled out for any work that you want to do. So that's o1. And then like if you want to remove the element, the first one, you can do that. For deleting a specific element which is not the first one, then it will be on, because the linked list would have to travel through each of the elements. In case of priority based queue, the main difference is because it is sorting and maintaining the order based on priority. The adding the element, removing it, and polling, those operations, the time complexity is log n. And for retrieval methods like peak, size, the complexity is constant time o1. And and contains also is linear time complexity. So in short, like based on your applications and on these differences, you should make a choice which one you should use. But it's good to know the differences, and they both are very powerful implementations which can solve a variety of problems with these. Let me know if you have any questions for me. I would be happy to answer. Thank you very much.